The second key concept when it comes to fluids is pressure. So what's pressure? The formula for pressure is force divided by area. So the idea is there's something applying a force on a surface somehow. And this can actually happen for fluids or solids. Let's imagine there's a box on a table. We'll give the box a mass and we're going to think about the volume of it too. So this box has a square base, 10 centimeters per 10 centimeters, and is 2 centimeters high, and it weighs 5 kilograms. So we can calculate the pressure. So first of all, let's think about the force. What's going to be happening is the force of gravity is going to be pressing down. This block is a simple free body diagram. The force of gravity is down, the force of normal is upwards. The force of gravity is going to be the mass times g. So that force is going to be 46.5 newtons. Now, what is the area which this force is applied over? That's the surface area. So I've highlighted in red the area where that block is touching the table. The force is evenly spread over that area, putting pressure downwards. So what's that area? It's going to be 0.1 meters by 0.1 meters. So the area will be 0.01 meters squared. With these two numbers, we can calculate the pressure. So the number we get is 4650. The units for pressure are something called pascals. So I'm just going to write PA there. They're named after some French science philosopher dude called Pascal. And the idea is this force is being spread over a certain area. So in the equation, if the area is larger for the same force, the pressure would be down. So if we imagine this same box had a larger surface area, it would be applying less pressure with the same force. If the box had a smaller surface area, it would be applying a larger pressure with the same force. Now what's interesting is that both fluids and solids apply pressure. What's a fluid? Well, let me just say this. Fluids include liquids and gases. So any liquid or gas with weight will apply pressure downwards, and any solid will also apply pressure. The best way to get an A on a test in physics is to do a practice test. On my website, there's a free practice test for fluids. If you click the link below, you can get the free practice test. We'll even mark it for you and let you know how you did. Let's look at an example of a liquid. Let's say I have a jar of oil on the table, and this oil is going to be applying pressure downwards. So how much pressure does it have? The formula is the same. So let's imagine there's 30 centimeters of oil in the jar, and the jar has a radius of 10 centimeters. We can think about it as a cylinder. Oil has the rho of 800 kilograms per meters cubed, so we can calculate the mass of this oil, and then we can calculate the force of gravity. So we need to use the density equation from last time. So what's the volume for the oil going to be? This is a cylinder. We think about our math, pi r squared times h, and we've got to put our numbers into meters, like this. And what's the volume going to be? 0.0094 meters cubed, and that's the volume, and we know the rho, so we can calculate the mass. So the mass is going to be 7.5 kilograms. The force of gravity is going to be this times g. So the force that's coming downwards from the weight of the liquid is 74 newtons of force. And now we're in a place to calculate the pressure. Pressure is force divided by area. I'm going to need to know the area as well. So this is the circle of the cylinder on there. That's going to be pi r squared. So I'm going to get that the area of the circle that's on the table is 0.0314 meters squared. And now we can calculate the pressure. So the pressure that this jar of oil applies is 2,356 pascals. So you may not have thought about pressure very much before unless you've done a lot of scuba diving, but pressure is a very important topic. Have you ever understood what pressure is before? Write in the comments below a time when you've seen a situation where pressure mattered, where there was a force divided over an area? Write in the comments below